Good morning or good afternoon, everybody. Thank you for joining us today for this webinar. My name is Raluca Petrescu. I'll be your host today, and I'm delighted to spend the next 40-50 minutes with you today, and also with two of Astadia's top experts to discuss how organizations can reach the fastest time to market with the least project risk by migrating mainframe applications. So today I'm joined by Scott Silk, Astadia's CEO, and Louis Heymans, Managing Director here at Astadia. And we'll be talking about mainframe modernization drivers and trends. We'll also give an overview of the Astadia FastTrack Factory, which is the platform, the software platform we use in our projects. We'll discuss the importance of automated migration and testing, and how the entire process of mainframe to cloud migration can be automated and standardized, and why it is important. We'll also look at a few examples of companies that have used the factory setup in their projects to accelerate mainframe to cloud migrations. Please write down any questions you might have or remarks so we can address them at the end of the webinar. Also, I've published a short poll on common mainframe modernization setbacks, and it would be great if you could just choose the option you find more relevant. It's also at the bottom of the screen at, in the poll tab. All right. That being said, I would like to invite Scott to open the discussion and touch a bit on the mainframe modernization trends or drivers that we are seeing in the market and where Astadia stands.
Good, thank you, Raluca. And you're gonna, let's see. Okay, slide number 1, we're in good shape. So thank you for that, Raluca. We represent the firm Astadia. We wanted to give you, I'll give you a 1-minute commercial on the company. We're the largest and fastest growing mainframe migration boutique. And a boutique is a specialty firm that specializes in moving mainframe workloads to distributed platforms as well as the cloud. When people move their technology, they move their mainframe workloads to the cloud. As an example, they typically either re-platform it or refactor it. Re-platforming being a COBOL to COBOL solution, refactoring being more COBOL to Java or COBOL to C#. And our technology that we'll be talking about in a little bit is really powerful. And one of the breakthroughs is we can move you to a COBOL environment or a Java environment or a C# environment, all at the same time frame and price point. We like to think we have some game changers in our technology, and I can't take credit for this. Louis is the founder, so this is Louis' brainchild. But we came up with that technology that we think is really going to really change the industry. And we now can move you to off the mainframe to distributed or cloud platforms in unprecedented timeframes and at relatively low cost. So the 5 things, when you think about Astadia, the 5 things that really make us unique are when we move code from COBOL to Java, most of the people in the marketplace are anywhere from 50 to 75% automated. And the remainder of a project is done manually. So you'll look at people doing the platform will do 75%, and then it's human intervention for that last 25%. I'm pleased to report that our technology has been enhanced throughout the years, and we're now at 99.9962% automated. So we have a real unfair advantage in the marketplace being the most automated platform. Secondly, this automation allows us to scale. And we have many Fortune 100 references at scale. Oftentimes, when people talk about refactoring, they'll be talking about pilot projects or departmental projects. And we have a very large list of Fortune 100 references running the entire enterprise at scale, which is very impressive. The third thing that we think is important to clients when they look at moving mainframe workloads to the cloud, Java or C# or COBOL, they want to make sure that when they're in the new language, that be it Java or C#, that the language is very maintainable and recognizable by a Java or C# developer. Bullet number 4, which is really important, is automated testing. And when you move workloads to the cloud, oftentimes testing represents 50% of the time and cost of a project. So with our automated code refactoring up front, that 99.9962% number, and automated testing on the back end, we've really set a new level of productivity in the marketplace when moving workloads. And if you think about it, if we're so automated on the front end and have automated testing, we can license this technology to both customers and partners alike. And we're the only one in the industry that has a factory licensing model. So we can always do the work for you, but if you elect to license the factory, we can set up a factory for you, a customer or a partner to do the work on your own. So we look at these 5 points as game changers for the company. They're game changers for both customers and partners alike. If you go to the next slide, please. When we start talking about this 99.9962 and automated testing, that's all well and good. That's very interesting. But where the rubber really meets the road is when you take a look at delivering in a cost per line of code model. And that's where the financial benefits are really become apparent. In an Astadia environment, the larger, the more sophisticated projects that we work on, the cost per line comes down with scale, which is diametrically opposite of other vendors in the marketplace. And why does the cost per line of code go down with scale? Well, we're eliminating 80% of the human intervention. We're having the software factory, our FastTrack Factory, doing the work. So in these large, complex projects, we can be down to as low as 15 cents per line of code, which is exponentially more cost effective than other solutions in the marketplace. Go to the next slide. I kind of get a kick out of this slide because when we presented the FastTrack Factory to a customer, and they said, "Congratulations, Astadia, you solved the industry's bleeding at the neck problem." And we're like, "Yes, we did. What problem was that?" And they kind of joked and they said, "Scott, there's 24,000 mainframes in existence today. And if those mainframe customers want to move to a distributed platform or the cloud, they need COBOL, CICS, DB2 resources, for example. Problem with that is the COBOL, CICS, DB2 resources, they're my age, they're Louis' age, and they're retiring. So there really aren't enough people to move those mainframes to a new environment. So in essence, the people that have to retire the mainframes will probably retire before the mainframe gets retired. The good news is, though, with our high degree of automation, when we put teams on projects, we eliminate the need for about 80% of these technical resources. So in a project with Astadia using our FastTrack Factory, it's like a 4-to-1 or 5-to-1 ratio, where you'll have one of these experts coupled with 4 or 5 business analysts on a project. And that eliminates the need for 80% of the heavy technical resources to do these migrations. So I thank you for that, for listening for my brief introduction. I'd now like to introduce and turn it over to our founder, Louis Heymans, who will get into the technology in a bit more detail. Louis?
Thank you, Scott. So, well, you have mentioned the word automation many times. And that is also, yeah, it's a central word in everything we do, automation. And automation leads to industrialization, which means that we can do a lot of things in a very short time frame, and we can do this with people that do not always need to be the real experts in, for instance, mainframe technologies or even the target technology. You can go to the next slide. So your modernization journey can look like this, or you go from your mainframe legacy applications straight to a complete modern looking, nicely re-architected with microservices and so on situation, or you can make a step, and that is the step that we present here. You can refactor your mainframe workloads to the cloud. So we will remove all the technologies, underlying technologies, and move it to, for instance, Java, C#, Kubernetes, containerized. And the reason why we propose propose this first step is that we do not want to mix risks. So we do a technical refactoring of your applications to the cloud. Can be private, public, hybrid, on-prem. But we don't mix things like doing a technical migration together with functional changes. So we don't do that. Okay. Doing what we call a like for like allows us to make it scalable. And also very important is acceptance by the client is pretty straightforward. So the result should be what is also running on a mainframe. There's no doubt if it doesn't give the same result, then there is something wrong and Astadia fix it. Scott already mentioned the testing tools. Automating the testing is pretty important in such a large project.
Hey, Louis, if I can make a comment, we're seeing some questions come in. I just wanted to let people know that we'll have time at the end of the presentation to answer questions. Okay. Yep. Thanks.
So scalability is very important thing. And mainly what is quite important is most of our clients, they know the ROI of the project when they start the project and not at the end of the project. And so there are no surprises. And if they make the next step, and all our clients, most of our clients make the next step. So this means that the end result of our refactoring is really a maintainable system. So the next step then can be done at their own pace, because now they can benefit from all these nice tools that are available in the target environment, and the money they saved in the previous step, they can use to step by step really modernize that their mainframe workload. Go to the next step, please. So automation is the word, and there are several levels of automation. Of course, yeah, if you migrate a mainframe workload, or even if you want to decommission a mainframe, it's a huge project. So you better have tools, and of course you cannot transform or convert or migrate all the different components fully automatically, but those where we talk about high volumes like source code, job control language, data structures, files, there you can use tools to fully automate the process. And I'm not going to go into detail with the tools that we're showing here, but like CodeTurn and DataTurn, and I think the name speaks for themselves. They are tools that we use to automate these processes. Of course, you cannot automate everything. Suppose you want to replace the work scheduler, for instance, a Tivoli work scheduler by Control M, then it's clear that this can only partly automated, and there will be certainly manual work involved. And of course, there is other things in a migration project, like if you are going to replace your infrastructure, there will be certainly manual work involved, or for instance, change management during a project. Yeah, suppose you have to retrain your developers to now develop in C# rather than COBOL. That will take, of course, manual intervention. If you go to the next slide, please. Now, the next part, and Scott already touched upon it, is the testing. Now, whatever IT project you do, testing is always a nightmare, I would say, or takes a lot of time, takes expertise about the systems, about the applications. If you can automate that, that is a big step forward. So that is the reason why we developed this tool, Test Match. And this picture is just a simplified representation of what really happens. If you look, Test Match is a tool that we developed, and that is sitting on a Windows box or on a Linux box. It doesn't touch the mainframe. So if you follow the lines, the arrows, like arrow labeled 1, first of all, of course, we migrate or convert the application to the target infrastructure or technology. Same with the database, if you look at the arrow labeled 2. And then we produce, or the client produces test scenarios. But the way these test scenarios are produced is not like writing on paper, but just users, and you see the users are represented there. They execute workload on the mainframe, can be in production, can be on a reference test environment. And during their actions, by switching on a tracing mechanism on the mainframe, all actions are traced, recorded in a log file. Of course, not every system, you as screen users, maybe there are external partners that connect to the backend through, like, for instance, Entyrix or TIBCO or Control M, sorry, MQ. Also, those middleware products, they have tracing mechanisms that can be activated. So during a certain period, tracing mechanisms can be activated, and then what we call a scenario is created. So the information is stored on the mainframe, and we can import that information in test match repository. Then we can replay the same scenario in the same chronological order, if you follow the replay buttons, on the target application. Of course, we have to make sure that the applications that are used are the same that we transformed from the mainframe. And of course, that the data is the same data that we converted from the mainframe. But during the replay, I will again record the results, transactions, in fact, that are now executed by test match, not by physical users or other ways to connect to the mainframe. And when the scenario is played, then test match will automatically compare what was collected in terms of results on a mainframe with what we achieved on the target system. By doing this, we can really test a lot of transactions of the mainframe without the need really of creating test scenarios, because they are created automatically behind the back of the user, I would say. And we can replay them on the target machine and see where there are differences. Now, as you can see, this allows very small teams to do testing without even knowing the applications, just looking at what test match brings after the analysis. If you go to the next slide, please. Now, we have been talking about tools to transform code, to convert data structures. We have been talking about test match. There's another tool that we have for the testing, which is data match. Now, all these steps that need to be executed, they have a certain order, logical order that needs to be respected each time we do a migration. For instance, if we do a Kobo Kix DB2 migration to whatever Java with Oracle on a Linux platform, it's always the same order that needs to be followed. All the steps need to be followed in the same order. What you see here is a typical Jenkins pipeline, and each of the nodes represents, of course, a step in the whole process. And it starts with taking in what we call a snapshot. I will come back to that later. A snapshot which represents, in fact, all the components, the artifacts from the mainframe that represent what the client is using at that moment in production. So source code, job control language, data structures, and so on. First step is always an analysis of the components, an analysis to make sure that whatever we received from the client is complete, and what we received is, we can handle it. Whenever there is in one of the nodes a problem, then the color will not be green, of course, and there will be another color, and each of the nodes will produce a log file, and then the factory people can inspect the log file and take the the action that is required to solve the problem. Once analysis is done, we go over to really converting, transforming code, JCL, converting data structures, and so on. And if everything goes well, we will then have a migrated system that then can be compiled, built, deployed, and ultimately go through regression testing, which is for which we use test match. This is the third level of automation. So first we have the tools that automate the transformations and the conversions. Secondly, we have the testing tools that automate the testing. And then third, we have this type of pipelines. These pipelines will be different for different types of migrations. For instance, if you migrate an IDMS application to Java, Oracle, whatever, it will follow, well, there will be other steps in this pipeline. The nice thing about the pipelines is that, and about the tools, of course, is that it's a controllable, repeatable, standard way of always doing the same process. Go to the next slide, please. Now, so far we talked about the tools that we use in the FastTrack Factory, but we also have a certain method in how we use these tools. Now, if you look at this picture, it's a simplified representation of what really happens. At the right-hand side, you see the phases of a migration project, the way we determine the phases. And of course, like with every project, I suppose, you have an assessment. So during the assessment, we'll take in a snapshot. And again, a snapshot are all the different artifacts, components that represent at that moment what is used by the client in production on the mainframe. So assessment consists of top-down and bottom-up. So analysis of all the artifacts for completeness, and yeah, we have to see whether there are constructions in the code that we might have never seen before that should not work but do work on the mainframe. So we might have to change our conversion rules. And then, of course, a few workshops to determine together with the client what the target technology, infrastructure, teams that are needed to run the migration project, change management that is required to come, in fact, to a project plan that can be used for the execution of the project. And of course, yeah, a cost that is related to that project. And then you see the four major phases of, well, the way we call them, phases of the migration project. So factory certification, well, the two first phases, factory, well, the name says it, factory, run completely in the factory in isolation. So, and each of these phases, they have a clearly defined acceptance criteria. And the acceptance criteria mainly are scenarios that are are collected from the mainframe that have to be played in the factory or later on the system of the customer. And when the scenarios execute correctly, then we can go to the next phase. Now, with factory certification, we aim to achieve completeness, meaning we have all the components that are required to run this application, and syntactical correctness. So we can convert, and the sources that that are the result, they compile and can be built. The next phase, the factory exit, there we go for isolated functional correctness. And isolated, why isolated functional correctness? Because in our factory, we can never build an infrastructure that mimics what the customer is using, the client is using. That would be not achievable. So we go for isolated functional correctness. Once we pass the second phase, we will bring the migrated application to the systems of the client. Of course, as I said, separate from these steps, while we are working in the factory, there are many other things, activities going on, like installing the new infrastructure if that is required, if they don't go to the cloud, change management, project management, and so on. Once system integration testing, everything will happen on the system of the client. And the exit for system integration testing is when there is integrated functional correctness. So at that moment, the migrated application will run on the systems of the customer, the testing systems, I suppose, and will produce exactly what is what the results are on a mainframe. Things that are part of that phase, for instance, could be performance testing. Once that step is made, we can go to user acceptance testing, where we aim for full functional completeness or correctness and non-functional correctness. Now, of course, these phases might take some time. And in the meantime, the customer will continue to maintain his applications on the mainframe. So from time to time, we will take in again a new snapshot. And why are we able to just take in a new snapshot anytime during these phases? Because if you look at the left-hand side, the spiral, you see convert, test, tune. Now, this is what has been shown by the pipeline. Now, this process is used over and over and over again in the factory, and the reason, well, one iteration, for instance, we can run the same iteration a few times a day sometimes, because when we speak about automation of conversion or transformation, we can do millions of lines of code in just a few hours. Okay. Then using the testing tools that can again test automatically, because just you have to imagine that sometimes we had clients that were tracing on the mainframe activity during 7 hours, and they could replay it with test match in the same chronological order, but with deleting the think time that users have, the same number of transactions in 15 minutes. So that these tools allow us to run over and over and over again the same process using the pipelines in the factory. So whenever we need to synchronize with what is then available on the mainframe, the real current production status, we can synchronize and just convert, test, and tune again. So we can repeat this process over and over and over again. Of course, when we encounter problems, with tune we mean sometimes there is a problem, and the problem can be configuration issues, or maybe sometimes we have to change some conversion rules. That happens. So we can run this over and over again. And finally, this leads to, of course, the final data migration, which then is followed by the go live. Okay. Now, this way of working provides a lot of an enormous flexibility. For instance, suppose that you're converting a VSAM file to a DB2 table on the target machine. Of course, VSAM files, they usually have a curse fields. Now, some people want to normalize the file so that in the target database, you have a parent table and then the occurs in child table. But by running batch workloads, it could be that you run into performance problems, because the way a batch program reads a VSAM file on a mainframe is a completely different mechanism than reading the same information in a relational database. So it could be that in the beginning, when we discussed about the data model with the client, we started with a certain data model, that later in the process we have to change that. Now, the fact that we can convert, test, and tune in a very short time frame and in many iterations a day, doesn't matter whether we have to change the data model again to denormalize or normalize other tables. So that's an enormous flexibility. And another enormous flexibility is that the code freeze can be kept to real near zero time, meaning for data structures, we ask the client to not change data structures anymore, like a few weeks before go live, and code can change until a few days before go live. Of course, when there is on the mainframe a critical error that needs to be fixed. Yeah, that needs to go also in the migration before you go live on the target premises. So an enormous lot of flexibility, and by doing this, it's a process that can be executed by let's say factory people. Those factory people don't need to be mainframe experts. We can do this work with a very small teams in a very short time frame, whereby we deliver. We do this in a controllable way, and it allows us to reduce time, and by reducing time, we reduce also cost. So the conclusion is, through the automation, we get a lot of flexibility, can make changes during the project. I can give you one example. We had a client a few years ago who started off the migration with going with the data to SQL Server, and during the project switched to Oracle. Perfect, no problem. So that is because of the automation that we have with this method. Okay. Now, because it's the intelligence is in the tools and in the method, so this FastTrack platform can be licensed to third party, even to clients. So we have a client, I suppose everybody knows Société Générale, the French bank. This French bank is using this platform. So their teams are running the migration to migrate from natural database to a target platform. So we don't have no interventions from Astadia. Of course, when they have questions about certain processes, we will provide support, but the real migration is done by the client. Yep. Okay, go to the next slide. So I have two cases where, well, in every case we use the factory FastTrack method and platform. But I want to show two cases. One case is Deutsche Bank Asset Management. So Deutsche Bank Asset Management is one of the 4 pillars of Deutsche Bank, and the most consistently profitable part of Deutsche Bank. It was a pretty challenging project. They had two mainframes, which we migrated to .NET, Natural to C# and Arbas to SQL Server. But the challenging part was the performance and also the volume of production data. They had 15 terabytes of production data that we needed to migrate in a pretty short time frame. So they could not just, well, the system needed to be up and running practically constantly. One of the remarkable things is that we managed to shorten the duration of one of their most challenging batch jobs from 180 minutes to 40 minutes. So, but in the second step, so we did a replatforming to .NET with C# and SQL Server, but their second step is, well, first of all, they had immediate cost reduction of almost 6 million euros per year. But in a second phase, they're now providing this platform as a digital investment platform for partners, institutions and even clients, private clients. So this is the largest digital investment platform in Germany at this moment. The second project we did for, if you go to the next slide, we did for Foyer, and Foyer is the largest insurance company in Luxembourg. Now, they had a mainframe running COBOL and EGL, which we migrated to DB2, LUW, and Java on a Linux platform with Kubernetes fully containerized. So we're talking about close to 9 million lines of code that were migrated to Java, fully automated using the factory for the FastTrack Factory. The nice thing is, so currently they want to move 50% of the former mainframe workload to the cloud. They don't need to do anything for it. It's cloud ready. The only problem at this moment is they have to wait for the government in Luxembourg to allow them to run this workload in the cloud. Because yeah, everybody knows that Luxembourg has a special how would I say, regulation with financial information compared to certain other countries in Europe. So they're fully on open structure. Kubernetes makes the switch to cloud trivial. And today, I had recently a discussion with them. They can provide faster new developments to the business than they could before. And that thereby this ends my part of the presentation. Thank you.
Thank you, Louis.
Thanks, Louis.
I think this would be a good moment perhaps to look at the questions we received. So I know there's one question in the chat asking about the process for conversion of VSM and flat files to DB2 or SQL. Is this something we can approach?
Well, the process, what we will do is we have a tool called DataTurn, and or we use copybooks, or we extract copybooks from the COBOL programs or whatever program that is accessing the VSM files. This information will be injected in the repository of our DataTurn tool. And from there on, we can, well, DataTurn automatically will propose a target data model, which is in general, always from the start, fully normalized model. But from there on, we can start to configure the target database, I would say. So if we want to denormalize certain files, we can. If we want to change names of columns, we can. If we want to change names of tables or file names, we can. So from there on, DataTurn will generate all the required components to, one, create programs to extract the data from the VSM files. So DataTurn, if you have a VSM file on the mainframe, will create a COBOL program with the required JCL to run that COBOL program. So you compile that program on the mainframe, and that allows you to extract the data from the VSM file, which data is then transferred to the target platform. DataTurn also generates the necessary components to create the target database with indexes and so on if required. And then you will use a tool which is, well, during the process, after the file transfer, data will be converted from EVCD to ASCII. And then usually the client will use, the client or the person who is executing the data migration will use the data load tool of the target database, SQL loader, whatever you have on the target platform. That is the process.
Thank you, Louis. And there's someone who wants to know what are the main considerations when planning on moving to the cloud versus moving to distributed platforms? So we can address this question too.
Can you repeat what are the determining factors or the?
Yes,
what?
when planning on moving to the cloud versus moving to distributed platforms.
Yeah, it's the customer who, or the client who decides. We are not deciding anything. We are quite agnostic about the target platform. We even have clients that migrate on the mainframe that want to move from CA IDMS situations to COBOL DB2 even. So whatever the customer wants to, client wants to, we will follow. And of course, yeah, sometimes people will ask our opinions, and of course we prefer to move off the mainframe to open systems, but whether it's in the cloud or on-prem, I think that's the decision that the client makes.
Sure. If I can maybe add something to that as well, that question gets asked of us quite often with clients. If I roll the clock back maybe 18 months, it might have been 50% of people would go on-prem, 50% in the cloud. There's been a dramatic shift recently. So right now it's probably 85, 15, 85% want to go cloud, 15 on-prem. And we see that trend continuing. We also get asked often as well, do you recommend that I re-platform COBOL to COBOL versus refactor COBOL to Java or C#? That too, 18 months ago was probably 50-50, 50% re-platform, 50% refactor. But we're also seeing a trend now leaning more toward refactoring as the workforce continues to retire and the COBOL resources are retiring. We're seeing a shift in refactoring over re-platforming.
Thank you. And also, technical question. There's someone saying that their vSOM files are compressed utilizing a custom compression algorithm. Are you able to place a decompression step into the data turn process?
We have been confronted with compressed files, so I'm not a technical person to explain exactly how it works, but no, we can work with it. Well, unless, of course, the client has developed its own compression. And of course, we need to sit together with the client. And but if it's a standard compression, yeah, we can. That's part of the migration project.
Thank you, Louis. I think we're running a bit out of time, so I would say we stop here for the moment. And if there are any other questions, we can follow up on email. And yeah, if also the audience would like to learn more about Astadia and our solutions, please visit astadia.com. Is there anything else you would like to add, perhaps? Louis, Scott, just like the main takeaway.
Yeah, I'll make the main takeaway. I mean, I know it was a big, bold statement we made at the onset saying that we can move you to the cloud faster and more cost effectively than anybody else in the industry. And we stand by that, but challenge us, allow us the opportunity to prove our capabilities to you. So when getting started with Astadia, oftentimes a customer will work with us to do an assessment or a proof of concept or a pilot. And we really love getting involved in relationships like that because that gives us the ability to demonstrate fastest path to the cloud and the most effective, cost-effective path to the cloud. And that's thanks to the great software that Louis built.
Thank you. Then thank you, Louis and Scott, for this great discussion, and thank you everyone for taking the time to join us today. And I hope I'll see you next time in our next webinar.
Thank you.
Have a good day, everyone.
Bye.